Hello friends, today I'm going to solve LeetCode problem number 491, non-decreasing subsequences. So in this problem we are given an integer array nums, and what we need to do is return all the possible non-decreasing subsequence of that array which has at least two elements. So the things that we need to keep in mind is it should be non-decreasing, and there should not be any repetition of the elements. Like let's see this example here. So we have this array and we need to get the subsequence of this array. So how are we going to start? We start from the first element. So from 4 we know that if the sequence, first of all the sequence, we start with an empty subsequence and then we add a 4 to that subsequence. So now what do we have? We have a 4 in our subsequence. Now is this of length 2? Of course not. Our result array is empty so far, and we'll only push those elements which are at least of length 2. So the array should be of length 2 at least. Now what we need to do is we need to insert another element, right? So we move on to the next element in this array and then we get the value 6. Now we check, is 6 greater than the last element in the sequence? Well, yes, 6 is greater than 4. So we add a 6 to our sequence. Now we know this is at least of length 2. So this will be one sequence that we are going to append to our result array. Next, we will keep on continuing with this sequence. So as we know, we have 4 and 6 in our sequence so far. Now we move on to the next element, which is 7. So is 7 greater than the last element in our sequence? It is. So we add 7 to our sequence, and again here its length is greater than 2. So we add this to our result array and we keep continuing with the sequence, the previous sequence we had. So next we move on to the next element. We have a 7 again, and 7 is greater than or equal, it is actually equal to 7, right? Equals to 7 means it's still non-decreasing, right? It is non-decreasing. Non-decreasing means it can be greater than or equal to. So since 7 is equal to 7, so we can add this value to our sequence. Now we can again append this value to our result. So far we have 3 arrays in our results, 3 subsequences. Now what we do is we backtrack from our sequence. So the last sequence we had was this one, right? So we backtrack from this subsequence. So what we'll get is we pop our last value from the subsequence. So we pop the last value and we get the value 7. And then what we are trying to do here is we are trying to perform an iteration. So for this subsequence that we have, we added this element, right, to form this subsequence. Now what are we going to do is, now we are looking for the next element after this one. Is there a next element? No, there is not, right? So we just return back to our subsequence and backtrack again. So since we do not have the next element, we backtrack and then this is what we have in our subsequence so far. So what is it that we have is 4 and 6. So we have 4 and 6 and we have already computed its next element, right? We have already iterated over the next element, which is at position 3. Now once we go to the next position, which is, okay, this is position 2 at index 3. So when we look at index 3, the value is equals to 7, right? And we know that 7 is greater than 6. So since adding 7 to this subsequence would make still keep it non-decreasing. However, we see that we already have that subsequence, right? We already have that subsequence, even though this was from the second index and this is at index 3, this values from index 3. However, the values are same, which is that we are actually creating a duplicate, which we do not want to create. So how do we avoid duplicates? We are actually going to use unique set. So we will be using a set where what we are going to do is, so we'll assume that we have a subsequence 4 and 6, right? So we have not moved so far. So from 4 and 6 we have the subsequence this. Now we set a new set every time we define a new set on and then what we do is, now since we are iterating over 7, we look at our set. So our set is right now set doesn't have any value 7 so far. So what we do is we add 7 to our set. Now in the next iteration, what we do is we now backtrack. So basically from this we moved on to this one, that is our next subsequence was this, and then we moved on to this one, and then finally we backtracked where our subsequence was now this much only, and then since we have already computed this value, we move on to the next step. So now here we see that we have a value 7 in our set already. So since we already have the value 7, so we are not going to perform this operation, that is, we are not going to add to our set. So that is then we move on to the next element, and since we do not have the next element, then we backtrack again, and then where do we reach is we reach the point where we only have one element in our array, that is 4, right? And since we already computed it for the value 6, now we compute it for the value 7. So next we'll have 4, 7 in our subsequence. And every time we iterate, like every time we are increasing our length of the subsequence, we are actually creating a new set. So for this subsequence we will have a new set which doesn't have any value in it so far. So when we then for this set when we then move to the next value, that is 7, next index 7, then we do not find the value 7 here. So that is when we can actually push the value 7 to this subsequence in this way. But when we backtrack again, and then when our subsequence only has the value 4, that is at this point we create our new new set, and now for each of the element that we traverse for that set, we are actually going to add it to the set. So we'll add the value 6 to our set, and then we'll get this subsequence. We add our value 7 to get the subsequence with value only 4 and 7, and then when we move to the next element, we see that we get the value 7 and we already have it in our set, so we do not execute that next step. So that is how we are going to avoid duplicates. Now let's dive into coding. So what are the things that we need? We need our result array, and then we need a subsequence array which we will be using over each iterations to backtrack, to move forward and then backtrack. So our subsequence will keep on changing, and we'll be using a helper method for that. So let me define the value n is the num's length. Let result equals to our empty array, and then our helper function we will pass the index I and then our subsequence array, and we are gonna define our unique set which is empty for every new function call. So now what we do is we iterate starting from the index I, and j is less than equals to n j plus plus. So why are we starting from index I? So index I means our previous subsequence. In our previous subsequence we have iterated up to index I. So let me just complete it and then explain it to you again. So what we'll do is we are going to check here if the set has the value at index j. If it has the value, then we are going to keep continuing to the next, and also we are going to check if the next element is non-decreasing or not. So non-decreasing means we need to make sure that the value in the last index of sub array is less than our current value. And for this to be valid, we also need to check if the length is greater than 0. So the length of the sub array should be greater than 0 and the value should be less than our current element. If it's not less than equals to, that is if it's greater, which means it's non-decreasing, then we are going to continue. That is, we escape all the next steps that we have. Else what we do is we add to our sub array the value j, and then we check if our length of the sub array is greater than or equals to 2. That is when we push this value, our sub array, to our result, and then we call our helper function to perform the next iteration, that is index j plus 1 and the sub array. Okay, so we need to push the copy of our sub array, and then finally we are going to pop the last element from our sub array that we pushed. So and then finally we are going to call our helper function at index 0 and return our result. Now talking about starting from index I, so let's see here, we are calling at index 0 with an empty sub array, right? So index 0 is value 4. So right now our unique array is empty, unique set is empty, so we start at index 0 since I is in the value is equals to 0. So starting from index 0, unique doesn't have that value, and also the length of sub array is less than 0. So we move to the next step where we push our value at index 0, that is 4, to our sub array, and then since its length is also not greater than or equals to 2, so we move to the next step, that is we make a call to our helper function with index 0 plus 1, which is equals to 1, and with our sub array with value 4 in it. So we call our index I value is now equals to 1. Okay, so I'll just write it here, and our sub array has the value 4. All right, and then we define our new unique array, and then we iterate starting from index 1. So now what we are doing is we are looking if 6 is not in the array and is less than or equal, it's greater than or equal to the last element, and it is. So we push to our value at this our array, and then since now the length is greater than or equals to 2, so we push to our result array and we call our helper function to the next element. So what we are doing is we added 4. Now we need to look for 6, so we are actually increasing the length of our subsequence here. So 4, and then next we added 6. Next, in the next step, we'll add 7. Given that it satisfies all the condition, in the next step we are gonna add this 7 as well. Then we backtrack at this point, at this step, and then we will only have this subsequence, and then we again backtrack to this position, and then from this for loop, right? So this for loop where it's increasing, the value of j is increasing, right? And at the position where we have our subsequence has the value 4 and 6, the index value is equals to 2, right? So we started from value 2, so j was equals to 2. We backtracked from 2, and then now we will move on to the next element, which is equals to 7. So that is what we do. So for this subsequence, j is equals to 2, then j is equals to 3, and so on. So that is why we start from the next because we have already evaluated these two, so we are actually going to start from the elements after these two, right, which is at index 2 and beyond. So that is what it is. Now let's run our code. Oh no, what's wrong? Oh my god, there are a lot of undefined values. All right. Okay, so it's not equals to, it's just less than n here. Okay, I'm still getting wrong. All right, so I have this unique value, so I defined it and I'm checking the value here, but I'm never adding the value to it. So I actually need to add it for the unique set to work, right? So I'm adding nums j here. A lot of mistakes I make. Let's submit it. So the time complexity of this solution is